So here we gonna see. I am Nilesh Pandey, and I'll start with my presentation. Here we will see what is XGBoost and gradient boost. The things that we'll see both applies for both the cases. First, we'll start with the regression case. Let's suppose we have age and income. Income is our target variable. We need to predict it with the help of age. So the average of all these incomes are 70,000. So initial prediction will be 70,000, and based on initial prediction and income, there will be a residual. Correct. This residual will be taken, and the best split will be find out by my model which has the highest gain. So age is less than 45. There are two things where age is less than 45, that is 25 and 35. So the tree is over here, and age is equals to or greater than 45 are the three leaf, right? So taking average of this, we got minus 30,000, and taking average of all these three, we got plus 30,000. So if you see where your age is less than 45, you will update it with the multiplier of 0.1, which is eta, that is the learning rate, and you will get your desired output, that is new prediction, to be 67,000. Since it is less, you have predicted it way higher, you will come close towards your income. So you can see we have a very good step of moving from 70,000 to 60,000, which is closer to 30,000, right? So let's suppose if your age is 50, this new prediction, this is the new prediction of only first tree, and you can develop several other trees which will be very close to your output column. For simplicity, let's start with predicting age equals to 50. Age equals to 50 is greater than 45. So your new prediction was 73,000. So the answer will be 73,000. When you build more trees, you will come more closer to this value, more closer to more closer to the appropriate value. In the case of classification, we have age and the loan was approved or not. One thing we have to keep in mind that this works on probability. So the probability of occurring one is 0.6. There are three occurrences of one. So your probability is 0.6, and the log odds of this value is, that is log of 0.6 by 0.4, which is 0.44 0.4055. So your initial log odds will be 0.4055. Keep that in mind. In XGBoost and um, in gradient boost, you always go for log odds. Okay, then you will see, if and you find out that your best split is at age is less than 45. See, your best split is for age less than 45. So what you'll do is you will split these criteria, that here when you split you will calculate the probabilities, not initial logouts. Okay, so your probability was minus 0.6. This minus 0.6 is like, uh, you have 25 and 35, the loan approved, the actual loan approved, didn't approved, so your value is 0. 0 minus 0.6 is minus 0.6. 0 minus 0.6 is 0 minus 0.6. But in case of 1, it will be 0.4, 0.4 and 0.4. But you cannot directly add the average these probabilities as you did in the case of regression. So you will take a transformation value. Similarly, for this case, you will take the sum of all these two values and divide it by the number of units. There are two units divided by, and your initial probability was 0.6. So 0.6 multiplied by 0.6 multiplied by 1 minus 0.6, that is 0.4. So you will get value as minus 2.5. And for here you will get 1.6667. If you see, and now you will update your previous logouts and come up with new logouts. So 0.4055 plus 0.1 times minus 2.5 e raised to minus 2.5 for the case of less than 45, and 1 point and multiplied by 1.66 for the case of greater than less greater than 45. So when you want to predict whether your age equals to 50, since age is greater than 45, your log odds value will be 0.5721, which is here. And when you put this into a sigmoid function, because inverse of log odds is sigmoid, so you will get the probability 64% chance that the loan will be approved. And now we'll see the Adaboost classification technique. Here you have age, you have target values, and the initial weight will be calculated as 1 divided by total number of samples. So here we have 5 samples, initial weight will be 0.2. Suppose we got the best split as age is less than 45. So for age is less than 45, age is less than equals to 45. I have taken less than equals to 45. So your predicted value will be 111, and for rest it will be 0. Okay, and your initial weight is 0.2. And if you see the weight of misclassified point, sum of misclassified weights are 0.2 plus 0.2, which is 0.4. So you will calculate alpha with the help of this error. You will take half multiplied by log of 1 minus 0.4 and divided by 0.6. So 0.1 minus 0.4 divided by 0.4. So you will end up having value as 0.203, and your new weight will be the multiplication of old weight in with the help of multiplication of old weight, that is 0.2 multiplied by exponential times you will add in the case of misclassification, and you will subtract in the case of correctly classified point. So new updated weight will be 0.163 and 0.245, that is present over here. Since you have calculated 1 alpha, similarly you will calculate 2 3 based on your trees, how much tree you, based on the how much point you build. So I have 3 alphas, and the best split I got for alpha 1 was less than 45, for alpha 2 was less than equals to 55, and less than equals to 35. So when I want to predict age equals to 50, I'll do 0.203 multiplied by 0, 0.203 multiplied by 1, because age is less than 55, then 1, and then equals to 55, then 1. So you end up having value 0.302, and putting it into a sigmoid function, you will get 65% chance of approval. If I say initial weight, that is if I have 5 samples, if I have 5 rows, so the initial weight will be 0.2. 1 divided by 5 is 0.2. How do you arrive at 0.302? Okay, so when you multiply, you first of all you have several alphas. So alpha will be calculated as it's shown here. when you build several trees. In this case I have built in this case I have built only one tree, so I have showed it for only one. You can build it for 3. So let's suppose we have values as 0.203, 0.302 and 0.15 as alpha values, and the best split were less than equals to 45, less than equals to 55, less than equals to 35. So age equals to 50 satisfies only one condition, that is age is less than equals to 55, so one will be present over here. And the weighted weighted splits will be calculated 0.203 multiplied by 0 plus 0.302 multiplied by 1, and you will end up having 0.302. This was just an example. This may not be very correct, but I mean, when you calculate different alphas, this is the method, this is the procedure that you will follow to calculate your predicted output. And I have explained how I got 0.203. I'll explain again. Your 0.20, you have two misclassified points, zero point 0.2 and zero point 0.2. Your sum will be zero point 0.4. So first thing you will do is put it into a function which has a formula of half multiplied by log of 1 minus error divided by error. So you will end up having 0.203, that is alpha 1. It's half multiplied by log. It's already given. I have not derived that formula. Exactly. Yes.